Hello all, this video is on DWIN ModBus RS485 master data transfer with AIAO input and holding registers. Here we have a 5-inch industrial grade DWIN HMI display. It has got A and B pins. This is RS485 pins, and on this we will be implementing ModBus protocol. We require USB to RS485 converter like this. When connected to PC, it will be offered a port number. Through this we will be implementing ModBus protocol data transfer, and we will be using this R2T2 with the RS232 connector. This is just to download only the 22.bin file, as we have to modify often the 22.bin file. We will be using this connection. A RS232 to USB connector is used in this method, and when connected to PC it will also offer another port number. Through this we will be downloading the 22.bin file. Other project files will be downloaded using this SD card method. Open the DGUS software. In the background images, the first image we have AI, and we use 04 command for input register read, and the next one is A003 command for holding register read, and the third image is for A0. We use 06 and 10 command to write holding registers, and we have a keyboard also in the next image. These are the supported register function codes. Hex 04 is used to read the AI register, and 03 is to read AO, that is the holding registers, and hex 06 and 10 to write the holding registers. In the first image, background image, we have AI, that is we use 04 command for input registers, and we use text to show and data variables, and VP 1000 for single entry, and multiple entry we use 1010 to 1013. And the next image is for AO, that is we use 03 command, hex 03 command. This is for analog output holding registers, and VP address is 2000 for single entry, and 4 more VP address 20102 2013 for showing multiple entries. And the third image we have A0, that is to write single register we use 06 hex 06, and for multi register we use 0x10. This is for analog output write holding registers. For single write we use this we use two methods. One is for variable icon and with incremental adjustment. This is at VP 3000, and at VP 3010 we use data variable, and over the data variable we use touch and data input, and we implement the keyboard. So on touching that 3010 VP, keyboard will open, and the keyboard is configured using basic touch and hex codes. You can check our previous videos on how to implement this keyboard on this page. On this keyboard buttons we use basic touch to implement the hex codes from 0 to 9, and then cancel and OK. So save this file, save this project, and then click on generate, so that the bin files are generated. Check up the project folder. We have inside the DWIN set folder, we have to include the .hzk file, and then go to the official website and kernel upgrade, and scroll down to select the ModBus master. Download this zip file, and under this zip file you have different zip files. You have to select the 9600 UART5, as we are going to implement ModBus on UART5 AB. You have to select this file, and inside this folder bin file is there. Copy only the bin file, .bin file, 9600 baud we are going to use, and UART5, and paste this bin file inside the DWIN_set folder of your project. And this 22.bin config file, you copy and paste it outside the DWIN_set folder, and after modification of config.bin file, 22.bin file, we will be downloading using the RS232 method, and we use PSPad editor to edit the 22.bin file. Open the PSPad editor and go to location 0x03 0x06 0x10. From there we will be including the commands, that is the instructions. And the basic project file will be that is DWIN_set. We copy to the SD folder and use the SD card method to download the project file. The project has been transferred to the DWIN display. Provide the power back 12 volt DC supply, and you can check the project in working condition as per the design. The page switching is working, and then in the third page you can see the variable icon working, and the keyboard pops up on touching on the VP 3010 and other VPs, and you can input the data using keyboard. Now let us design the communication between slave and master. For this you have to modify the 22.bin file. Go to location 0x13 000. From there you can provide all the instructions we'll be using after that. 0x13 010. Instructions starts with 5A, and then the slave ID is 01, and the command is 04, which is AI read input register, using the command 04. And we'll be using for single entry VP is 1000. So after this command you have to provide the data length, which is 01, which is for single entry, and 50 is the timeout 50 millisecond, and 01 is the mode. If you're using mode 1, you have to provide the page ID after that. Page is 0, so 0000, and VP address is 1000, where to show the data on DWIN, and where to get the data is 0064 of slave, which is nothing but 100 decimal. You can download the PDF file given in the description. And for slave we'll be using PYMODSLAVE. This is open source software simulator. PYMODSLAVE is an excellent slave simulator. No installation is required. Unzip the folder and double click the application file. You will see the PYMODSLAVE screen. We'll come back to this after modifying the 22.bin file. Go to the 22.bin file and provide the second instruction, which is for multiple entries. So 5A is instruction and 01 is slave ID. 04 is the command. Now for data length use the 04. This is from 4 registers we'll be getting the data. So 04. After that 50 is the timeout. 01 is the mode, and the page ID is 00000, and VP address start address is 1010. From there 4 locations we display the data, and from slave we get the data from 006C, which is nothing but 110 in decimal. So save this configuration bin file, 22.bin file, and then we use the RS485 method to download this bin file to the project. So go to setting and dgas, select the T5L download, and select the 22.bin file. Correct bin file you have to select. We have saved it outside the DWIN_set folder. Select this 22.bin file, and then select the correct COM port. Here we use the RS485 to USB cable. If you check the device manager, USB to serial COM3 is allotted, and then click on download. Now 22.bin file is being uploaded to the DWIN display. Only the 22.bin file is uploaded now. Now let us check from the PYMODSLAVE. From PYMODSLAVE options, select RTU, ModBus RTU, and then provide the correct COM port that is allotted to the RS485 to USB device we are using. That is baud rate is 9600, and 8 and 1, 8 data bits, no parity, and 1 stop bit. Mode is RTU, and slave address is 1, and the starting address is 100, that is decimal 100, 064 in hex and decimal 100, and quantity is 50. So 50 registers will be displayed. Click on connect. You can see the 50 registers of slave being displayed. Now you check up the DWIN display while changing the data from the PYMODSLAVE. So at location 100, that is 0064, we are going to change the data. Select the AI, that is the input register. We are going to read input register using command 04. Change the data at 00, that is a 100 location, decimal location. You get data 44 on the DWIN display, that is single entry. For multiple entry, we have provided the decimal addresses 006C, which is 110 of slave. Go to 110 of slave, you change the data there. You can the data being reflected on the DWIN display. At the bottom, you can see the 10102, 10113, 4 locations. We are going to update this 4 VP address from slave. First, you change the data at for 1010. So change the data at 110 address of slave, that is 006C. The data being displayed at 1010 VP in real time. Go to the next address, that is 111 of slave. Change the data. So all these 4 address data is reflected on the DWIN display. So this is input register read using AI and command 0x04. We modify the 22.bin file accordingly, and then we show the demo. The next page is AO, that is read holding registers using command 0x03. For single, we use the VP 2000, and for multi, the VP starts from 2010. Now let us edit the 22.bin file. Go to location 1C030 and provide the instruction. Instruction starts 5A, and 01 is the slave ID, 03 is the command, and 01 is the data length. 50 is timeout, and we use the mode 00. That means on all pages. So the next 2 bytes are 0000 only, and the VP is 2000, and slave address location is 0064, which is nothing but 100 decimal. Same way for multi, we use command 5A 0103 command, and data length is 04, timeout is 50, mode is 00, and page not to be mentioned, so 0000, and start VP address is 2010, and slave address is 006C, which is nothing but 110 is in decimal. So now open the PYMODSLAVE. Before that, upload this 22.bin file using the RS485 method and the T file download. Select the correct comport and then click on download. The 22.bin file has been modified in the DWIN display. Now open the PYMODSLAVE, and here select the AO, that is the holding register, and start address is 100, number of registers 50. So change the value at 100, the value will change at VP 2000, and for multiple data entry, change the values starting from 2010. You can see the data being changed. The data address at 110, that is the slave address, decimal is 110. So if you modify that, starting from 110, all the 4 datas will be updated on the DWIN display. So this is AO, which is read holding registers using 0x03 command. These 2 commands, 0x03 and 0x04, are read commands from slave to master. The next one we will see the write commands, that is from master to slave. A0 write single register using 0x06, and A0 write multi using 0x10. Now let us modify the 22.bin file and provide the instruction. 5A, 01 is the slave ID, 06 is the command to write single register, 01 is the length, data length, 50 timeout, and the 00 mode, so that next we have to provide 0000. And the VP address is 3000, where we have variable icon. On touching that variable icon, 1 and 0 will vary on the slave address, and the slave address is 0082, which is nothing but decimal 130. And the next instruction is to provide the keyboard input. Here we provide a 0601 5001 and then mode 0002, and the keyboard input VP location is 3010 and slave address is 0083, which is nothing but 131. Save this bin file and upload this using RS232 method. Now open the PYMODSLAVE to test the instruction we have provided. That is, note the locations of slave address 130 and 131. 130, from DWIN we will be touching the variable icon at VP 3000. So when the variable icon changes, it will change data to from 0 to 1 at address 0082, which is nothing but 130. Note down from DWIN display, we are just touching the variable icon on page 2. Touch on the variable icon on and off, and notice the location 130 decimal on the slave. According to the variable icons, the data changes from 1 and 0. Same way, the next VP, touch on that, keyboard will pop up, provide the feed in the data value. It will display at location 131 decimal, which is 0083. So this is command 0x06, that is A0 write single register. And the next one, we'll see the write multi-register using 0x10. This 0x10 can be used for single register also. Let us modify the bin file for this. That is for to provide the instruction for this command 0x10. Command is instruction is 5A01. Command is 10. The data length, first let us try 01. Timeout is 50, and then 01 is the mode. So we have to provide the page number after this. Page number is 0002 and VP address is 3040 and slave address is 0078 hex, which is nothing but 120 decimal. So we are using the 10 command to write single register. It can be used for multi-register also. For this, the instruction is 5A01 10. 04 is the length of the data, and then 50 is timeout, and mode let us use the 01. So we have to provide the page ID, which is 0002, and VP address starts from 3050. From there we will be updating 4 registers, and the slave address is 0064, which is nothing but decimal 100. Save this 22.bin file, upload it as usual using RS232 method. Now the instruction has been uploaded to the DWIN display. Let us test it. Open the PYMODSLAVE. Notice the locations 100 and 120. First is the 120 location. This is from write single register. So from DWIN display, feed in data at 3040. The data will modify on the slave at location 120. And for multi, feed in from 3050. The keyboard will pop up. This is from master to slave. So we are feeding using keyboard. So at first at location 100 0064, the data will vary. The next VP address 3051, 3052 as well as 3053. All these 4 VP address data will be transferred to the slave starting from location 100, which is 0064 in hex. So this is 0x10 command, write command. This we are using it for single as well as multi-register update. Next we will see how to update all the 4 VP address data from 3050 just by touching a single button at the VP 3100. At VP 3100 we use return key code and we provide key value as 005A and VP address is 3100 low byte. So we check for this low byte 5A, and if it is found, we will update the data starting from VP, total 4 registers, to the slave slave ID. For this, let us modify the instruction 5A01 and command is 10, length of data is 04, as we are going to update 4 BP address, and then 50 is the timeout. Now the mode is very important. It is 02. Previously we used 00 and 01. Now we use 02 mode, and then we have to provide the VP address 3100 where we are looking for the low byte 5A. So when low byte 5A is found at 3100 VP, then we have to provide the VP address 3050 starting VP and address of the slave 008C, which is nothing but 140. Now save this 22.bin file and then upload it to your DWIN using RS485 method. Open the slave PYMODSLAVE and notice the locations 140. Provide the key in the values at the locations VP address 3050, 5152, 53, and finally touch on send at 3100 VP. You can see all the 4 data being updated on the slave starting from 140 address, which is 008C in hex. So all the data at a time being updated, all the 4 VP address data starting from 3050, 3051, 52, 53, we key in using the keyboard. Data is fed using keyboard. Finally, we touch the 3100 button. All 4 VP address data being updated to slave starting from decimal address 140. Thank you for watching.